Perfect. So, an introduction to AI and machine learning. So, to begin, I just want to set out what our objectives are going to be for this particular class. So, first and foremost, I'll need us to understand AI and machine learning basics. So, basically, we want to grasp the fundamental concept with simple, clear expectation. And I'm assuming at this particular point you have no technical knowledge about this. And again, that is not even required because you're starting from the basics. So that's going to be our objective number one for today. Our objective number two would be to differentiate the key fields in these industries, that is AI, machine learning, and data science. So we'll want to clearly distinguish between AI, machine learning, and data science with practical examples and how they differ with each other, including the careers that they come with in each of the areas. Then our third objective for today will be to discover AI applications relevant to daily life in Kenya and Africa in general. So after we have identified AI and have looked at different key fields that are there, we're going to look at now the practical examples where we use AI and machine learning as far as Kenya and Africa in general is concerned. Well, we might go beyond Kenya, but of course, we're going to use applications that are within the country, like Netflix and YouTube and maybe voice assistants or things like that, which are basically not really African technologies, but we have a way of using them within the country. So, as an icebreaker question, maybe I can just ask a question. Where have you interacted with AI today? And probably, maybe you could look at things like uh, uh, your morning routine or something of that sort. So, where have you interacted with AI? If you have interacted with AI before today, anybody interacted with it before today? And what was it all about? Now, I'm not on my screen where I can be able to see who is in attendance, but you could just unmute your mic and talk to us, then we can carry on. So nobody has used AI today. And I'm not talking about ChatGPT. I want simpler applications or solutions that are within our grasps. If you look at your mobile phone, for example, what kind of AI have you used? So for most of us, and especially if you have a mobile device that uses fingerprint or facial unlock, you've actually used AI today because that's a practical application of how AI works. So fingerprint unlock, facial unlock, we're going to look at what kind of AI that is, but those are basically AI. The other one is voice recognition. Maybe you have issued some instructions via your phone. It's able to take your voice, convert the text, the speech that you have given it to text, do some online search, give you some feedback, or perform some actions. That is actually AI. You've also used social media. Probably today, and probably on social media, you'll find that either Facebook or Instagram or WhatsApp will be giving you feeds that are on your interest, the things that interest you, things that people, your friends are interested in, and so forth and so forth. That is also another application of AI in our day-to-day lives. They are basically the things that we do on a daily basis without actually even realizing that they are there. So that is a practical uh, 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 those are practical things that you have interacted with today as far as AI is concerned. Of course, you're going to expound on that further. I just want us to understand that AI is not as complex as people assume it is. There are those simple things that you do. Recommendation systems from Netflix or even YouTube, they'll give you things that might interest you based on the things that you've watched before, based on your friends, based on the people, what people are saying within the country, and so forth and so forth. So without the algorithm, just looking at it plainly, that is actually AI in motion as far as we're concerned. So as part of objective, this is what you want to understand how they work today. So as I said, AI is applicable in our daily life. So if you look at what you've encountered within the last 24 hours, you might be surprised that AI, like most people assume, isn't just about robots and science fiction movies. It's actually working behind the scenes in the apps and services that we consume every single day. As I gave us an example, we have smartphone unlock where you have facial recognition or fingerprint scan. That actually is AI. We have Google search, which autocompletes and has what we call smart results. It will be able to give you results closer to your area. For example, if I go to Google and I search a particular model of a laptop, they'll probably give me ads that are closer to Kenya or Nairobi or Nakuru or Mombasa. If I am in Mombasa, that's actually smart search or smart results. But it can actually autocomplete. I simply say HP ProBook, then it can be able to suggest. It's actually called live search. It can actually do a live search and do auto suggest on the kind of HP ProBook that I might be interested in. We also have something like M-Pesa and mobile banking, which have what we call fraud detection and transaction analysis. Fraud detection, M-Pesa can be able to easily tell if you are trying to perform some fraud. Maybe you're trying to withdraw some money in various locations at odd hours, for example. That is how they have implemented the algorithm. And in that particular way, they will be able to block you from actually performing those transactions. And probably maybe even doing transaction analysis. If I try to send money based on a certain pattern over and over again, it'll simply tell me, wait, there is a transaction of a similar nature currently ongoing. Kindly probably wait for some time, or use a transaction of a different amount, or pick a different number or something of the sort. Then you also have WhatsApp and social media, where we have smart replies and content recommendation. Again, as I said, when you go to something like Facebook or Instagram or any social media like X for that matter, you'll kind of like find that the content that is given on the feed that you are accessing, even Discord, is very relevant to the things that you like. If you like politics, that's what you can find there. If you like technology and information, you'll find that there. If you like products and services, you'll find that there. If you like other things, probably like makeup and all that, that's kind of like the things that you're going to get on your feed. Now, for smart replies like WhatsApp, you can actually create a bot that is capable of responding to customers, like a chatbot, for example. I don't know if you've used Zuri by Safaricom. If I wanted to cancel an M-Pesa transaction, I'll simply go to Zuri and paste the message over there. It will automatically be able to detect that this is an M-Pesa transaction, and probably this person is trying to reverse the transaction. It can be able to give you your PUK number. It can be able to unlock or lock your device on request, and so many other things that would actually need a customer care agent to be able to do on your behalf. But the AI can actually be able to do it for you. We also have Google Maps for doing things like traffic prediction and route optimization. Like for most of us who are using Google Maps, I want to maybe come from say Ngong to say Nairobi CBD. There are quite a number of routes that I can be able to take if I am in Ngong. But of course, these routes are going to be optimized so that it's not only looking at the shortest distance between Ngong and CBD, but it's looking at the traffic. It's looking at if there are construction place going on. It looks at things like maybe say tolls if they're there and stuff like that. So when it comes to traffic prediction and route optimization, there are several factors it factors in order to give you the best route possible for purposes of implementation of of uh, of your route moving forward, right? So of course, if this was a physical class, I would pair you and ask you to share examples of what you've used today, and probably maybe be specific about what you did. Maybe for the interest of the class, because we are a virtual class, maybe one or two people can tell us based on the things that I've mentioned, like smartphone unlock, Google search, M-Pesa or mobile banking fraud detection, WhatsApp on social media content recommendation, and things like smart replies, where you have bots that can respond to users' requests and things like that. Google Maps for traffic prediction and route optimization. What AIs have you used today, and how have they been helpful? Then maybe just one or two person can tell us. Then we can move on to the next element. I know you use this every day, so it might not be new. Maybe you didn't know they are AI based, but probably that's why we are here. We want to see exactly how they are constructed from behind the scenes, so that when we get the application from the front end, we also understand how the engineering behind the scenes actually work. What data is it given? How does it predict, look at the data? How does it predict patterns? How does it come up with models that can now be able to predict the future? Actually, the second part is identifying patterns, not predicting patterns. It's identifying patterns. Then using those patterns, it can create a model for predicting what will happen in the future. For example, Google Maps, when you change your route, it will automatically reroute, optimize the route, and give you the next best alternative route based on the change that you've made in real time. So that's actually very, very powerful if you look at it from that angle, right? So any AI you've used today? And maybe you can be specific about what you did with it. Okay. Let's look at definitions and core concepts. So I want to define these terms one by one. What is AI? What is machine learning? And what is data science? So I'll define each one and every one of them, and I'll give an analogy for each of them for us to reinforce what they actually mean. So by definition, AI or artificial intelligence is the abilities of computers and machines to perform tasks that would normally require human intelligence. So it is where a machine or computer has ability to perform tasks that would require human intelligence. For example, a car driving itself. That is a forte that was left for human beings, for example. Uh, you know, robots can learn, robots can learn how to weld seams and do things like that. They can carry things, they can move from place to place, they can be able to identify obstacles and all that kind of stuff. That is basically what you're saying AI is the ability of computers and machines to perform tasks that would normally require human intelligence. For example, I can give you a list of photos of things and I ask you, identify for me the things in this photo. Are they cats? Are they shoes? Are they, you know, uh, chicken? And if they're chicken, what breeds are they and stuff like that. That was really a forte that only human beings could be able to do, but we are now trying to train computers and machines to be able to perform the same tasks. Now, the similarity between this and humans is just like this. Humans learn from experience and AI learn from data to make decisions, recognize patterns, and solve problems. So just like humans will learn from experience, and I'm going to give an example which I've listed on the left-hand side as a child. When you're teaching a child, we learn from experience. We experience things, then based on the experience that we have gained, we can be able to do things later on into the future without actually even having seen or interacted with them in that future. But based on our experience, we are able to achieve that. AI achieves that by learning from data. It will be given a lot of data. It will be able to recognize patterns in data, and then based on the patterns that it has identified on that data, then it's now able to solve problems. The analogy of that to teaching a child is as follows. Like, for example, when you go to lower grade schools, we show children examples. Like, for example, you can give them pictures of cats and dogs, different colors, different breeds, different sizes, and so on and so forth. So we can give a cat that is black, another one that is has multiple colors, maybe brown and white, another one that is black and white, another one that is purely white, a different breed of a cat, a different breed of a dog, and so on and so forth. Then, of course, the child learns the patterns. For example, they want to recognize the features. Like, for example, cats will have shorter whiskers, dogs will have longer noses, and things like that. The dogs are bigger. All of them are walking on fours, and all this kind of stuff, right? So they are able to learn that if I have these uh, properties or features, then this is most likely a cat. Then if it is bigger in size and all that, then it's most likely a dog. So that is learning a pattern. Then, of course, now they can make a prediction where the child will be able to identify newer animals in the future. If I showed them a German Shepherd and I showed them maybe a Belgian Malinois, they are able to tell that all of them are dogs, in as much as they are different breeds. But of course, they can see they have long nose, they have elongated noses, for example. They have bigger mouths with sharper teeth, and probably maybe they're walking on all fours, and maybe probably their sizes is averagely this size, so they're able to identify animals or dogs or cats into the future, even without having interacted with them in that near future. So that is kind of like how AI works. It learns from data, which is examples, to make predictions on newer situations. Now, classical examples of the kind of AIs that we have are voice assistants systems like Siri from iPhone. We have Google Assistant for those who are using Android devices. We also have Alexa for those who are using Amazon products. So all these are voice assistants. What they basically do is that they can be able to learn how you speak. They can be able to extract whatever you're saying and convert it into text, do some search, or even just within itself perform some actions that you want it to do. For example, if you have a smart home, it can switch on your lights, it can play your favorite music, and that kind of stuff. So it can read your messages, it can reply your emails, the likes. So it's basically an assistant that you can interact with using your voice. Then you have chatbots like in customer care and in healthcare systems. So in customer care, like Safaricom, for example, I want to offer services to my customers to reset their PINs, to block their lines, to cancel or to reverse M-Pesa transactions, to get their PUK, and so many other things that I would not need a human being to do. So I can have a service like Zuri, for example, and using Zuri, I can be able to give them a way that they are able to interact with that particular chatbot, and it is able to determine what they want to do based on the data that is available. Then it can be able to perform an action without actually being exclusively programmed. We're going to look at the difference between traditional programming versus AI programming and where AI-based traditional programming in that particular matter. Then another use case for AI in the current scenario that you're looking at in terms of learning, in terms of getting data. Then based on that data, it's able to predict to identify patterns, then predict the future. We have recommendation systems, like for example, YouTube. YouTube will try to learn the kind of things you like watching. You like war movies, you like comedy, you like cooking, you like makeup, and the likes. So as it is trying to generate recommendations for you, it's not only going to base it on movies alone. So probably maybe you like movies that are action based or science fiction, or maybe you like movies by a certain movie star, or maybe you like movies that have been produced by a certain studio or something like that. So it's not only going to look at you like movies and just recommend any movie for you. It's going to look at all these other factors and try to determine what best works for you. So you can see all this is data. You'll give it quite a lot of data. It will be able to try to determine the patterns in that particular data. It will try to look at what are others who have watched similar movie also watching, and what is the similarity between you and them. So it is kind of like able to determine that, similar to Netflix. And again, I'm not talking about the algorithm of Netflix and YouTube. I'm basically talking about from a principal perspective, how exactly does the recommendation system works. It basically picks the data that is there, it tries to identify a pattern on the data, then using a predictive analysis model, it tries to give recommendation for things that it thinks you might be able to like, and most likely 90% of the time you will find that it is correct. Jumia is another classic example of how AI can be used, because it will try to look at the things you like browsing on their website, the things you've stored, maybe things you've bought before, what other people have bought, and versus the item that you've recommended in terms of maybe say, are they complementary? Maybe like when you buy a pen, most likely you're going to buy ink, or when you buy a laptop, you're most likely going to buy a charger and a docking station, because that's what most other people do. So that is kind of like how those are kind of like how the examples of AI systems we have in place: voice assistants, chatbots, and recommendation systems. They're not the only ones, but they're the things that you'll probably find all over the place in terms of application and based on analogy of artificial intelligence. That is basically giving the computers and machines ability to perform tasks that would previously have required human intelligence. All right. Then, as I said, that was the general definition of AI. The technical definition is that AI is a branch of computer science that is focused on creating systems capable of performing tasks that require human intelligence, such as visual perception, like self-driving cars. They have cameras. Cameras can detect objects, and they can be able to detect distance. They can be able to detect speed and such like stuff. These are things that could be done only by humans. They could also be things like speech recognition, whereby I can talk to a computer. Like right now, there is a tool called WhisperFlow that I use for doing most of my typing. It will be accurate to 99.8%. It will put proper punctuation, intonation. Generally, when it comes to converting what I'm saying to text, it's really, really very good. I know most people take that for granted, but take somebody who has an accent like an Indian, for example, and then you try to dictate. Even for you to detect what they're saying might be a bit of a challenge, but for AI, it will actually be able to tell that because they've been given quite a lot of data concerning that, and it's able to know that okay, this person is speaking in English, but they are an Indian, or they are speaking English, they are Nigerian, so this is Pidgin English, and in Pidgin English, this is what I can translate it into normal English. Well, assuming that the translation is not supposed to be verbatim, then probably it can paraphrase it or things like that. So speech recognition. The other one is decision making. Again, these are things like, for example, when you're talking about maps, and maybe you're taking a route and you have taken a wrong turn and the map needs to reroute and stuff like that. Well, even if you were looking at a physical map and somebody has taken a wrong turn, you can imagine how long it would take you to be able to reroute, check again from where you are to the destination, determine the route that's most efficient and all that. You could actually do that, but it will take you quite a long time to achieve the same. So the other use case or the task that we're talking about is language translation. Somebody is speaking in Chinese. I want to translate that in English, or maybe we're in a church and the translator is a non-English speaker, but most of the speakers are English. They are Korean. You can do live translation right now. Or when you travel to a country where they're speaking Portuguese and Portuguese is not your forte, all road signs are marked in Portuguese, everybody is speaking Portuguese, you can literally have a system in place that can do live translation in real time. So I can be able to see road signs, what they mean. I can be able to speak to somebody. They'll speak, it converts it to text, converts it to audio in English, and vice versa. And we now remove the barrier of requiring a translator between us. So that is the technical definition of AI, a branch of computer science focused on systems that are capable of performing tasks that require human intelligence, such as the examples that I've listed. Now, what are the key characteristics of AI? One, as you have said, it learns from data. So AI systems analyze large amounts of data to find patterns and make decisions. So you cannot have AI without data, in short. It will always consume large volumes of data so that it's able to determine patterns from that data. Then those patterns it can be able to use to make decisions. We're going to look at the three types of learning that are there when you're looking at machine learning, because it's a branch of AI. So again, the more data AI processes, the better it becomes as it does. Just like human beings, you are you usually gain more experience as you do something over and over again, and you encounter different scenarios over and over again. You become better at it. And then the third characteristic is that it mimics human intelligence, which means it attempts to replace how humans think, learn, and solve problems. A very classic example I've just given you is translation, for example, language translation. Having a translator, if I was to use a difficult word like homogeneous, and this is a basic English speaker, there would be a challenge for them to do the translation, or they might probably need a workaround to be able to understand that. AI would actually not have that problem because the glossary is very, very rich. And as we said, you can give it as much data as possible. It doesn't have the physical limitation like a human being, where they can only be able to learn a few things at a given go. So how AI systems work, this is a simple version. One is data input. You can give it images, text, numbers, data from sensors, data from databases, both structured and unstructured data. You can read emails and all that kind of stuff. So that's one way of, or that's one of the things that it requires, data. So you input data from whatever source, whether it's a camera, it's from a sensor, it's from a database management system, it's reading from emails, however it's collecting that data. Then secondly, based on that data, it pattern learns. It tries to learn the pattern in that data. So it will find patterns. For example, it's just like, I'll give you an analogy. If I gave you a heap of clothes and I asked you to find patterns within the clothes, how would you go about it? Well, first of all, you might try sorting them by colors. Maybe say black here, red here, you know. yellow here, and so forth and so forth. Then I might want to find the type of cloth. Are they trousers? Are they blouses? Are they coats and all that? Then I can go ahead and try to find them by brands. Are they Hermes? Are they Tommy Hilfiger? So one or another, when you give me a heap of clothes, I will try to categorize them so that now I am able to find a pattern. So I can say I have trousers, I have them in this number of colors, and I have them from these particular brands. That's kind of like how pattern finding works. Then, of course, based on the pattern, I can be able to predict that this person is a lady because what I'm seeing here are blouses, and most of them are pink in color, and they are Hermes or maybe say a brand like Chanel or Banana or something like that. So probably based on that, I can make a prediction that most likely these clothes belong to a lady. So if I was to recommend buying clothes, probably I recommend buying women's clothing or even shoes to go with the clothing or things like that. That's kind of like how the prediction analysis or decision making works as far as AI is concerned. So that is AI, and those are the key characteristics. And of course, that is simply how it works. So let's look at a brief history of AI. I'm only going to look at the key milestones because it's been quite a while since we had AI. So AI started way back in the 1950s. Actually, to be precise, in the early 1940s to 1950s. And basically, it was developed by a gentleman called Alan Turing during World War II. That is from 1939 to 1945. So Alan Turing basically asks, can a machine think? Then he proposes a test to determine if machines can exhibit intelligence, which will make them indistinguishable from humans. And this laid the foundation for AI research. How did he actually achieve this? You'd put a computer and a human being in two separate rooms with the respondents on the other room in clear glass. Then you'd ask the machine questions, you'd ask the human being questions, and you'd be able to get the responses from both. If you could be able to detect which one is the computer and which one is the human being, then the machine was not artificially intelligent. But of course, during that experiment, they realized that it was impossible to tell the difference from the expert and the computer system in place. So they probably gave more or less the same answers, and it was almost impossible to tell that this is the response from a computer and this is the response from a human being. Now, this came as a result of what was called the Enigma machine. The Enigma machine is a tool that the Germans used in World War II to be able to send out messages via radio. And of course, via radio, it means anybody who could be able to detect the frequency you're operating on and tap into it, they could be able to read the data. But of course, you realize that the Germans were intelligent enough because they had the Enigma machine. And that gave birth to a lot of things. Like if you're talking about encryption right now, it still comes from that particular technology, but I'm not going to focus on that. So for the Enigma machine, it needed the data was encrypted, which means even if you were able to tap into the exact frequency, then you could not be able to decipher the message. What that means is that yes, you could be able to listen to the message, but now you could not be able to make sense out of it because it was gibberish. Now, even if you had an Enigma machine, which the Britons were able to get, you will still need the initial configuration of the machine, how it has been set up, so that now it is able to work, to be able to reverse engineer the message so that you're able to read it. So you needed two things. First of all, you needed the Enigma machine and the initial configuration that was put there so that now you are able to reverse the message and be able to decode what the Germans were actually saying. And that was an advantage in the war for quite a long time until Alan Turing and his team were able to create a machine that was able to decode that. And that was actually where AI started becoming AI and computer in general started becoming very, very real at that particular point. Of course, in 1960, there was a chatbot called Eliza that was created. So it was one of the chatbots that simulated conversation, and it used simple pattern matching to respond like a therapist. So it was a precursor to modern chatbots. Then, of course, in the 1990s, we had what we call the Deep Blue Beast chess champion, where IBM Deep Blue defeated the world chess champion, who is called Garry Kasparov, if you know him. And this proved that AI could master complex strategies, thinking, and dominate headlines for worldwide. Again, chess is not a very easy game, but if you could train a machine well, not physically training it. Of course, you're going to see how we can train machines. And so that it can be able to beat a chess grandmaster, it tells you exactly how intelligent machines could be. Personally, I like playing games like Scrabble. And Scrabble is a board game that requires you to be able to make words um, um, uh, in a board. And of course, based on the word that you have made, you will get points on that. So the computer is very intelligent. It can score bonuses based on the words that are there. Of course, it has a dictionary, and based on the dictionary, it can be able to create better words than you. So even if I'm a good Scrabble player, the computer will most likely, most of the time, beat me pants down as far as that is concerned. Now, of course, in 2010s, we had Siri, Alexa, and Google Assistant that were created, and this brought AI into millions of homes and pocket, whereby there was natural language processing inbuilt into the devices, and this was a huge leap forward because now you didn't need to type the instructions that were to give to the AI. You could basically just speak it. It will be able to pick that, whatever you're speaking, convert it to text, perform search, get the results in form of text, take that text, convert it to speech, speak it out for you, or something like that. I know that sounds simple and easy. Technically, that is actually very, very difficult, as you are going to see. But again, now during that time where now Android and, uh, and iOS, which is iPhone operating system, came into existence, then now they started leapfrogging as far as natural language processing is concerned. Natural language processing is also a branch of AI which deals with now converting speech to text and also vice versa, text to speech. So that now I'm not able to tell whether it's a human being talking or it's a person talking. And I can talk to a computer as I was talking to a human being, and it's able to understand what I am saying and it's able to take instructions in that particular manner. So that's actually very, very powerful. Look at it this way. For example, like Google Maps, I can simply launch Google Maps. I hold the microphone. I'll simply tell it, I want to go to Kangondo Road, maybe a certain joint. It will look for the route, and then it will do what you call turn by turn speaking. So it will tell me once I reach a particular turn, I can take left turn, I can take right turn, I can proceed straight for maybe a number of kilometers and all that. All these things is not programmed, it's not exclusively programmed to do. It will just be able to make that up and speak to you as a human being. So that's really huge. Then of course in 2020s we had things like generative AI, which is quite a big explosion as far as AI is concerned. So right now we can be able to generate text, images, codes. Like I'm a computer programmer, I'm able to generate code, music. I can even do videos. Now we have deep fake all over the place, and this is really powerful. So things like ChatGPT and all the other large language models that are there have made AI accessible to everyone. So now we're in the era of artificial intelligence democratization, which means that anybody can create any tool with AI and we will be good to go. So that's the brief history of AI from 1950 all the way to 2020s. Of course, I know we are in 2026, so there's quite a lot that has been done. And of course, if you look at the internet on a day-to-day basis, you probably find newer models coming up. Like if you go to a place called Hugging Faces, which is more like the GitHub for AI, you'll probably find about some thousand language models that are there. That is very, very huge. From generating PowerPoint presentations to writing computer programs to generating videos to doing images, writing computer codes. In fact, the entire software development pipeline life cycle, you can be able to do it with just AI. You don't need to know how to write code. You can actually be a hacker without writing a single line of code. So that's where we are at. So that's the brief history of AI. So let's look at the types of AIs that are there. So generally, we have two types of AI. That is narrow AI and general AI. So narrow or weak AI is what we use today. So narrow AI or weak AI, as you read them in some other textbooks, are basically AI that is designed for a specific tasks. For example, it excels only on one thing but cannot transfer knowledge to other domains. I'll give you a very classical example, something like facial recognition. When facial recognition patterns are very powerful, they can be able to detect whether you have grown beard, you are wearing goggles, you are wearing a cap, you've put on contact lenses. You've put on makeup. It's able to detect that this is you. But of course, it cannot do language translation, right? Facial recognition cannot do language translation. So we have facial recognition as one thing, it's doing one thing only. We have language translation, it is doing one thing, language translation. It can't do facial recognition, right? Then you also have maybe playing chess or Go, like playing Scrabble. The AI has been optimized for playing Scrabble, and it will play Scrabble only, or it will play chess only, very, very effectively. We also have self-driving cars. They can only drive themselves. They probably cannot do other things like maybe do welding or things like that. Unlike a human being where I can drive a car to work, then I leave the work, I go to my computer, type code. Once I'm done, I simply go to a production environment, configure a server, move it from one place to another, and I can do so many other things. AI cannot do that. They are basically built for specific tasks, and that's what they do. So, in short, they cannot be able to transfer their domain from, they cannot be able to transfer their knowledge from one domain to another one. So, that is where we are at the moment, the narrow or weak AI point. Then you have what we call general AI. Um, and this is what we call strong AI. It does not exist yet, but hypothetically, what they're saying is that it can understand, learn, and apply intelligence across any task like human beings do. A human being can be a welder, they can be an architect, they can be a mason, they can drive a car, they can drive a crane, they can do translation from one language to another, they can be able to identify different people, different things, and all that. They can teach. Literally, a human being can do so many things. So general AI or strong AI at the moment does not exist, but of course, maybe in the future we'll be able to have it. And then the other thing they're saying is that it could transfer knowledge from one domain to another. It can reason abstractly and also possess consciousness, which is what we call, it can be sentient. Sentient means it can feel, it has some sort of consciousness like a human being. It knows that this is wrong, this is right, right? At the moment, we don't have that yet. So this is basically fiction as we are speaking right now. So, what are some of the characteristics of general AI? It can learn any task, it can transfer knowledge across domains, it has abstract reasoning, and it is self-aware. Or maybe they assume it's going to be self-aware. We don't have that yet. So we are going to focus on narrow AI. This was just knowledge to know for us to be able to understand that we have these two types of AIs in place. So the key takeaway here is that all AI we interact with today is narrow AI. General AI remains theoretical concept and subject of science fiction movies, like we see in movies like, if you like science fiction movies like Transformers, where we have uh, uh, machines that can transform into cars, and they also have inbuilt weapons and their intelligence and all this kind of stuff. For the moment, that is still science fiction. We are not there yet. Maybe in the future we're going to get there, but at the moment, not yet. So those are the types of AI that are there. So how does AI work? This is the conceptual level. No math required. Again, remember we said AI is made up of several fields like machine learning and several other things, but we're going to look at that slowly. Let's just look at generally in terms of a conceptual level, how does AI work? So four things it does. One, it collects data, which means you gather large amounts of data, images, text, numbers, sensor data, and so forth and so forth. Then number two, you try to find patterns within the data. So you analyze the data to discover hidden patterns and relationships. So when I look at a heap of clothes, for example, like I'd given you, what kind of pattern is there? Are they based on a certain color, for example? Are they based on certain types of clothing? Are they based on a certain brand? Are they based on a certain size? Maybe all of them, if I look at them, their trousers and most of them are waist 34, something of that sort. So there'll always be some sort of pattern that you are going to be looking at when it comes to that data. Then, of course, the third thing it does is that it creates rules. So does what we call building internal rules based on the patterns that it has discovered. So I've discovered that this data has this pattern. So what are the rules that I can be able to apply to this data? So you create the rules. Then, of course, now based on the rules, you can make predictions. Here we're saying, based on the rules that you've learned, how can I be able to predict data? How can I be able to apply the rules to new unseen data and situations? For example, like a self-driving car, it will collect data about a road surface, probably maybe how people are driving. Are they driving on the left or on the right? It will be able to check the turns. It will be able to check are there construction activities going on the road and so forth and so forth. So if somebody was to be able to apply maybe a search and they're going to follow on that route, it's going to base its decision on that data and say, because I think there's a lot of construction going on here, this road might be very slow. Or maybe because of construction going on and it has rained, because based on the weather, most likely the road is flooded. So it can be able to predict and give an alternative route to the one that it has data on and stuff like that. So that's how patterns are detected. The rules are created, then decisions are made based on the rules that have been created. And basically, it's all about the data that is available. I can use the analogy of a child to how this works. So, teaching a child to recognize animals, and what you do is you show them hundreds of animals, maybe cats and dogs, in terms of photos. And probably here, the child will observe patterns. Like, for example, they notice that cats have whiskers and dogs have longer noses or snouts. And probably they'll build a mental model which will create an internal rule for distinguishing these animals. Then, of course, giving them a photo of a different cat, they should be able to say that this is a cat and this is an animal. And exactly that is how AI works. Data collection, pattern finding, rule creation, and of course, predictive analysis or making decisions based on data. So that is how AI would work. Now, let's look at AI examples. As you have looked at, we have voice assistants and chatbots. So how do they work? So these voice assistants use what we call speech recognition to understand spoken commands, processes the requests using AI, then respond with spoken answers. Clear examples are Siri, Google Assistant, and Alexa. So what can they really do? Most of them are installed on your mobile device, so you can set reminders, you can play music, you can control your smart home, you can answer simple questions like it can go do a simple online search, then give you feedback. For example, I can ask it, what is the exchange rate for dollar today? That's a very simple question. Or it could simply do something like, I have $100. How much is it in Kenya shillings? That's kind of like how answering question is. So it is not really programmed on what you're going to tell it, but it's going to look at the context, going to look at the data that you're giving it in terms of text, in terms of speech, convert it to text, do a search, then get the feedback, then convert the feedback, which is text, back to speech and speak it out to you, or even give it out to you on the screen of your mobile device or something of the sort. So that's a clear example of how narrow AI is used. Then, of course, is chatbot, which is automated programs which will simulate human conversation, and they can answer questions, provide support, and also assist with tasks through text or voice interfaces. Common uses, as we said, is customer service, like if you've interacted with Zuri, where now you can just give it a message and a message that you have sent money to a wrong number, and it will try to reverse it for you. It might not be it might not get it 100% because if you send money to a different to maybe say a pay bill number, most likely it's not able to reverse that. But if I send it to a human being, it will try to contact the person, try to find out if the money was sent wrongly before it reverses or stuff like that. So that's very, very important in doing. So those are examples of AI, voice assistants, and chatbots. We also have self-driving cars where we can have sensors and cameras. Um, the car is capable of detecting human beings. It's able to check the distance between an obstacle and itself. It is able to calculate how fast something is moving. It is aware. It has sensors, maybe in the front and the back. It's able to detect any other objects that are coming close to it or things like that. So it's able to make decisions as it drives itself. So again, you have sensors and cameras which will see the road or other vehicles or pedestrians. We have AI processing which will process this data in real time. Then you also have decision making which will steer, brake, or accelerate safely. We also have fraud detection, where we have banks and mobile services using AI to detect suspicious transaction in real time. For example, M-Pesa can flag unusual activities like transactions at odd hours from different locations. I'm using the same mobile phone, but I'm in 3 different locations. That is most likely going to be fraud. We also have medical diagnosis, where AI will analyze medical images like X-rays or MRIs to detect diseases early, sometimes more accurately than even doctors, because they can be able to see that I'm expecting the size of the kidney to be this, or I'm not expecting to see this in the kidney, however small it is. Sometimes it might take doctors ages to be able to see that. So it does that better. So we have also language translation. Apps like Google Translate use AI to translate between languages, instantly breaking the communication barriers that we have. So in context, we can also use AI in agriculture. So we have AI-powered agriculture solution, like for example, drone monitoring, which will monitor crop health analysis. So it will basically just flies through your farm. It takes images of your crops, then it compares to what a healthy crop should look like. That should be able to tell you whether there are pests and diseases in your farm, or it could also be able to predict weather and optimize planting time. So it can check that the weather for now, based on what you want to plant, is not very conducive. The rains are going to be more than necessary, or it's going to fall short. So probably maybe you might not want to plant at this particular time, and so on and so on. That is now prediction, right? So now let's look at the AI system that you've used before. This was supposed to be a classwork or an activity, but again, I think I'll just skip it. You can maybe do it much later on. What I wanted us to understand was the categories we wanted to consider on how we have interacted with AI. And I was looking at 5 different categories, which is communication, like WhatsApp replies or email spam filters or autocorrect, or maybe say even entertainment like YouTube or Netflix or Spotify, the recommendations it gives you, and maybe finance, things like mobile apps or M-Pesa or fraud alerts, or maybe even shopping, how you Jumia or Alibaba or AliExpress, or even if you're using this other one is called what? There's another one that rivals Jumia in Kenya, I've forgotten its name. How exactly do they work? Then you also have navigation, Google Maps, Uber, and all that. How do they estimate distance? How do they estimate fare and that kind of stuff? I know you have never asked yourself, how exactly does Uber estimate exact fares, considering or keeping in mind different routes that you can take, different traffic situations that you might have on the road, the amount of distance you're likely going to cover, how surges work, because when they surge, the prices will go up, or things like that. So all this is AI into action. So I just wanted you to consider those 5 categories and look at what you've used before and try to understand exactly how the algorithms work, because you cannot exclusively program all these things into your system. AI has to be inbuilt so that now it is able to operate efficiently. Again, you could be able to do that task later on once we are done with the class. Then you can give your feedback in the next one. So that is AI. Then now let's look at what we call machine learning, or ML. Machine learning. So what is machine learning? Basically, we want to understand how machine learns from data. So machine learning is basically understanding how machines learn from data. Let me give you a classic definition of machine learning. Machine learning is a subset of AI. So all machine learning is AI in short. So there is no machine learning that is not AI. But not all AI is machine learning. Just like saying all apples are fruits, but not all fruits are apples. So machine learning is a subset of AI which enables computers to learn from data and of course improve from experience without being explicitly programmed. A subset of AI that enables computers to learn from data and improve from experience without being explicitly programmed. What does that mean? Instead of writing specific rules for every situation, we show the computer examples and let it figure out the rest of the rules by itself. So instead of telling it exactly what it is to do, let's give it data, let it come up with the rules based on that data, then figure out what to do next with the next information that we give it. That is basically what machine learning is. So let's look at analogy rather of machine learning to riding a bicycle. So when you want to ride a bicycle, on your first attempt, you will try to balance. You fall off, you get the feedback, which is pain. You know that if I fall off, it's going to be very painful. So you try to make sure you don't fall off. The next thing, you practice and adjust. Your brain learns from that mistake and you now adjust how to balance. After you do it so many times, you get better. Now you can ride without thinking. Simply hop onto the bike, start pedaling, and there you go. You know how to ride a bicycle. And of course, the fourth is you master the skill. Now you can be able to ride the bike, or you can ride any other bike, whether it's a BMX, it's an electric bike, it has fat tires, it is a size 26 or a size 29. You can literally be able to ride any other bike because now you know how to balance, you know how to pedal, you know how to steer, and given that a bike would most likely have all these things in place, now you should be able to ride a bike more conveniently. So ML works the same way through practice. So through practice, which is data, and feedback, which is machines improve at tasks. So when it comes to machine learning, three key things are very important. One is data, where it learns from. Two is learning, which is finding pattern. Of course, three is improvement, which means it wants to get better over time. So we have machine learning versus traditional programming. Let's look at the differences. So in traditional programming, like what we do 90% of the time, human beings will write code explicitly for every situation. So for example, it's like, how do we compute pay as you earn? We will have to write all the rules. We'll have to write all the rules for all the input situations. Now, that's not very convenient when it comes to artificial intelligence application because rules will be based on data. It's just like saying, I want to get the shortest distance between I want to get the shortest distance between uh, point A and point B. I don't know which point somebody is going to pick. So for me to actually predict that and create it into an application as a rule, that might be quite a task. The other one could be something like spam filter. I cannot write all the rules for filtering spam because what I could do is I'll say if the email contains with money or free price, then mark it as spam. But what that means is that the spammers will just change the arrangement of the text so that now I have to keep on constantly updating my algorithm over and over again so that it's able to detect spam. That is not very, very efficient. So that's the problem that we have. So if you're talking about something like scammers, uh, 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 detecting spam from scammers, they just change tact on how they write their mails so that now they're able to beat the rules. So when it comes to machine learning, the approach is different. So the human being will provide data and answers. So for example, the computer will learn and set the rules by itself. So for example, we'll give it a lot of data and the expected output. Then it will learn and create its own rules. So for example, the approach would be to create a spam filter, we'll give it 10,000 emails that are labeled spam or not spam. Then it will learn from the pattern, what is a spam email out of these 10,000 emails? Then it tries to detect the pattern that is there in terms of wording, in terms of case sensitive, in terms of urgency, and any other pattern that it can be able to find. So that is the difference between machine learning and traditional programming. So the key differences in summary is that in traditional programming, rules are manually written. Same input will always be give you the same output. It requires constant updates and is best for stable or predictable tasks, something like computing pay as you earn, where I just give it tools and tell it, these are the payments, these are the deductions, these are allowable deductions, then this is the tax table, which is fairly consistent for quite a very long time. That way, it will be able to work. But something like calculating the shortest road distance between two places for doing something like a map application would not be very convenient because a user can change the route. There could be traffic in one route, the road could be closed, and so forth and so forth. So I don't have control of so many variables on this. Now, when it comes to machine learning, rules are learned from the data, which makes it very, very powerful. It improves with more data. As you give it more data, it becomes better. It adapts automatically, which means as I get data and I detect the pattern, I'm able to see what that data means. And it is best for complex or dynamic tasks like, for example, chatbots, as you have seen, natural language processing or voice recognition, text to speech applications, maybe things like home automation, where I can give it instructions in so many ways. In home automation, I don't need to tell it reduce the temperature. I can simply tell it I'm feeling hot. That simply tells that I want it to reduce temperature. So when it comes to programming that, you can see that reduce temperature and I'm feeling hot, I have to program the two things exclusively so that it knows exactly what to do. But when it comes to machine learning, then it is able to tell that when I say it's hot, it means I want the temperature to be reduced or something of the sort. Now, let's look at how we can actually train machines. There are three ways that you can train your machine language models or machine learning models. So when it comes to machine learning, there are three ways to train it. And one of the ways to train it is what we call supervised learning. So this is basically learning with labeled data. So here, the concept is very simple. Here, what we want to do is that it's like a teacher who provides correct answers. So you want to give students some data, then you provide them with the correct answer. So the AI is trained on labeled data. So for example, where we already know the correct answer. And the algorithm here is like, for example, flashcards, where at the front we have the photo of a cat, and at the back the label says cat. So when you study so many flashcards, we're able to learn and recognize what cats look like. Because we're given a photo, we're told this is a cat. Given another photo, we're told it's a dog. Given another photo, we're told it's a bicycle, right? And that goes on and on and on and on. And it's able now, as you continue doing that, I'll have thousands of photos of cats, different breeds, different colors, different sizes. Some are fat, some are thin, some are furry, some are skinny. So I'll have multiple photos of cats, and from there it reinforces my learning. That's called supervised or reinforced learning. So here, an example that you'd use for supervised learning is email classification. So the task is you want to classify emails as either spam or not spam. So you need to give it training data where you have thousands of emails that are labeled correctly. This is spam, this is not spam. Then that way, based on that data, it is able to detect what is spam and what is not spam based on the pattern it finds on the data. The pattern could be the agency that the data is written on. The pattern could be maybe suspicious links. There could be shortened links, and so many other things that you can be able to use to detect fictitious um, fictitious emails. The other one could be house price prediction. So the task could be predict prices of a house based on features. So you want to give it training data on house features, for example, size, location, and actual prices, so that if I gave it a house in a different location, then it can be able to predict for me the price of that particular house. Very useful for things like mortgages or evaluation, so that I can be able to check if the person requesting for the mortgage, are they being realistic on the application even before I go to the ground. So it becomes more like the first filter on that. We also have image recognition, where we want to identify objects in a photo. So here we train photos with labels on what is in them. So for example, if you want to train AI on detecting things like tables or cats or dogs or cars or buses or bicycles, then you actually use what we call supervised learning. So supervised learning is based on two things. It's either classification, which means you're predicting a category or a label, or regression, which means you're predicting numerical value, something like house prices or temperature forecasting or stock price prediction. I want to predict the price of this stock into the future based on the data that I have on it. What is the likelihood of the price going up or down? That's called regression analysis, and that's another application of what supervised learning is all about. So it's either you classify the data or you use regression analysis when dealing with numerical data for supervised learning. So that's one of the ways that we train our machine language models, supervised learning. The next one is unsupervised learning. So in unsupervised learning, it's like exploring without a map. So you want to find hidden patterns on your own. So the AI will analyze and label data, and of course, we have no correct answers that are provided. And of course, they discover structures and relationship by itself. An analogy here is like saying sorting laundry. When I give you a heap of clothes, as I had shown you earlier, you have no one tells you how to sort them, but you can actually group them by color, type, owner, shape, and so many other things. Then from there, you can try to figure out, well, what is this data all about? Are they male clothes? Are they blouses or coats? Are they suits or things of that sort? Simple examples will be things like customer segmentation, where you want to group customers by behavior. So the AI will find natural groupings like frequent buyers, bargain hunters, or even window shoppers. So it can be able to detect that for you. Then you can also do things like anomaly detection, where you want to find unusual patterns. So the AI here will learn normal behavior and flag anything unusual, which is more like how fraud detection works. For example, all of a sudden, I am depositing money on a daily basis. Previously, I was doing it once or twice a month. Now I am doing it over and over again. What exactly has changed as far as my account is concerned? Then you also have recommendation systems. They also use what we call unsupervised learning. So here, they want to suggest products or content. So the approach here is that the AI will group similar users or items and recommend based on patterns. So that way, it is able to recommend what most likely you are able to like or not. So in unsupervised learning, we have clustering, where you group things or group similar things together. We have dimensionality, which dimensionality reduction rather, which simplifies the complex data. Then we have association, where you want to find patterns or relationships between the different components that you have. So in unsupervised learning, those are the key components that you want to look at: clustering, dimensionality reduction, and association, finding relationship between the content of your data. Then thirdly, we have reinforced learning. This is learning through trial and error. So the concept here is reinforcement is where you want to learn through trial and error with rewards and penalties. So what happens is the AI agent will interact with an environment, take action, and learn from feedback. That is either a reward or a punishment. So the analogy is like training a dog. So when a dog sits on command, it gets a treat or a reward. When a dog jumps over the coach on the other one, it gets no treat or a penalty. Over time, the dog will learn best behaviors. Okay, so that way it makes it very, very easy for you to actually train the dog on best behavior. Now, applicable examples of reinforced learning are game playing, for example. So here, AlphaGo learned how to play Go at superhuman level. So it learned by when it won any game, it was given a reward. When it lost any game, it's given a penalty. So it knows that if I get a penalty, it means I've done the wrong thing. There's no right answer here. I'm basically just exploring with trial and error. If I get a reward, it means I am right. If I get a penalty, it means I am wrong. The same case applies to robotics, where robots learn to walk or grasp objects. So when they have a successful movement, they are rewarded. When they fail, then they are penalized. Another classic example of reinforced learning is a self-driving car, where the car learns how to navigate traffic. So when it arrives safely, we reward it. If there is an accident, then we penalize it. So in short, there is no wrong or right answer. It's basically whatever action or decision you make, we're either going to reward you or penalize you. Reward means you've done the correct thing. Penalty means you've done the wrong thing, and as such, that should not reoccur again. So every penalty means that these are the don'ts. Every rewards means that these are the do's, and so forth. And so it can be able to try as much as possible to implement the do's and ignore or avoid the don'ts rather, as much as it possibly can. So what are the key components in reinforced learning? One is the agent, which is the AI learner. There is something that's going to learn. Then there's the environment, the world that it interacts with. Then, of course, you have the actions, what the agent can be able to do. Then we have rewards and penalty, which means these are the feedback signals. For a reward, it's positive. For a penalty, it's negative. So when you're talking about reinforced learning, those are going to be the four key components that we need to be able to understand. One is agent, environment, action, and rewards. So let's look at examples of machine learning when it comes to email spam detection. How does it work? Well, there are four steps in machine learning, as we said. Number one is you collect data. So here we're going to gather thousands of emails and label them as spam or not spam. Then we train the model. So the machine learning system will analyze the emails, find the patterns, and distinguish spam from not spam. Now, based on the patterns that they've learned, they'll create identifiers, which is suspicious words, sender patterns, or even formatting as far as those emails are concerned. Then they will deploy and filter. So the model here will filter new emails automatically, which is going to improve over time. So this is very important. As you can see, we only need to give, say, 10,000 emails, which are properly labeled. From there, it's going to learn, take the data, try to learn the pattern in terms of what who is the author, what is contained in the email, are there any suspicious links, what do the links look like, where they're pointing to, are they spoofed, and all that kind of stuff. Then of course, once they learn that, then they create system to be able to filter out those things, then they deploy those particular filters, and then you're good to go. What AI learns when it comes to spam email are things like suspicious words, something like free, urgent, click here, and so on and so on. The other one could be sender patterns, unknown senders, spoofed email addresses. Unknown senders is the email does not have the name of the person who was sent. It's just an email address. Spammers mostly they don't have time to create a proper name because the emails are created automatically anyway, so you cannot give them real names. They just have a valid email address. Spoof addresses instead of Yahoo, it's written Yahoo, WYAHO instead of Yahoo, or Gmail is written GMM or GMMAIL. That is Gmail with a double M, something like that. That's a spoofed address. So it will look for things like that so that it's able to detect whether this is a suspicious email or not. Formatting, maybe all caps, excessive punctuations, and all that. It means that somebody don't take their time to proofread the email. You also have things like suspicious links where the links are shady or they are shortened so that you don't know where they're going by default. So it runs those patterns and tries to check. Based on these patterns, I think this should be classified as a spam email. Then it automatically send that email to spam. When you go to the spam and say this is not spam, it will try to learn why did I make it spam and what makes it not spam. Because if I look at all the parameters, probably there's one that I left out, and maybe that validation doesn't necessarily mean that it's spam. So that is how it kind of like lands. So why traditional programming will fail in this is that every time we need to write rules for every spam scenario, and this is impossible. Spammers will constantly change tactic. There are too many variations to code manually, and of course, new spam types emerge on a daily basis. So when it comes to spam detection, I am not able to exclusively program my system to be able to achieve such. So the advantage of ML is that it learns to adapt automatically to new spam patterns, and then as spammers evolve their tactics, the ML model learns from those new examples and also improves its detection without human intervention. So you can see AI becomes powerful over time. The other example of machine learning is image recognition. So how does image recognition work? So you show an ML system, thousands of labeled images, cats, dogs, and people. It learns the pattern. So the system learns visual features like shapes, colors, textures, edges, and so on and so forth. Then this recognition now it can identify objects in new images never seen before. The key insight here is that the AI learns to recognize features, not memorize specific images. It tries to learn features. If you give it a table has 4 legs, but there's also a possibility that a table has 1 leg, right? Because there are those tables that have only 1 leg, there's those that have 4 legs, there's those that have 2 legs on either end. So it will depend on how many photos you give it as far as tables are concerned. So it does not look at the object, it does not memorize the image, but it looks at the features of that particular image. So another example of image recognition is medical imaging. AI will analyze medical scans to detect diseases early. For example, X-rays. They look at and detect fractures and pneumonia. We also have MRIs or magnetic resonance imaging, which identify tumors, brain anomalies, and so forth and so forth. Then you have retinal scans, where it can diagnose diabetes, glaucoma, and that kind of stuff. Again, as far as image recognition is concerned, the other example will be facial recognition. So we have medical imaging and facial recognition. So here it is used for phone unlock, security, photo tagging, and so forth and so forth. I don't know if you have gone to Facebook and you can see that it can automatically detect the faces on a photo and even suggest the people you can be able to tag on those images. That is actually how facial recognition works at AI level scale. So you could even use airport security. If somebody has been flagged as a suspicious person and the image has been uploaded to the system, AI can be able to try and detect for all the faces it sees on camera, if a face is recognized as a threat, it can be able to follow that particular face to wherever they're going, which makes it much, much secure. Okay, so that is how you can use AI for image recognition. You can use it for classification of items, you can use it for medical imaging, or you can use it for facial recognition. So let's look at our last topic for today, which is data science. Data science. So data science is an interdisciplinary field that uses scientific methods or processes or algorithms and systems to extract knowledge and insight from data. So in short, data science is not one thing, but it is a multidisciplinary field which will use scientific methods, processes, algorithms, and systems to extract knowledge and insights from data. So the analogy is like a detective. So when you look at a detective, they gather clues, which means they collect data. Then they analyze the evidence, which means they look for patterns in that evidence. Then they solve the case, which means they extract insights. So whenever they collect data, they will try and analyze patterns in that data. So if there are 10 robberies that have happened, they will take all the 10 robberies. They'll try to look at the patterns. At what point do these people come in? How do they come in? How many people are involved? Are they using violence? And all this kind of stuff. So that is analyzing the evidence by looking for patterns. Then once they find certain patterns, then they can now solve the case. They can simply come and say, we believe that this is a group of 5 men aged between 30 and 40. They are heavily armed and they target mostly financial institutions. So if we were to catch them, probably would put a high alert on any financial institution that probably maybe deals in certain commodities, so that now we can be able to solve that particular case. So that's kind of like how data science works. So you can see it's not only one field, because there is gathering the data, there is analyzing the data, and then there is extracting insight from that data. These are very distinct areas of expertise that requires somebody to be able to be very specific on the expertise that they have in that particular key. Now, the three key components in data science is you need statistics and mathematics. So here, you want to analyze the data, find the trends, make predictions, and use mathematical models to be able to predict what might happen in the future. Then you also need programming skills, where you'll need to write code to process, clean, and analyze large data sets efficiently. Then there's what we call the domain knowledge, where you need to understand the specific field, whether it is healthcare, it is finance, it's agriculture, to ask the right questions. So if you don't have a skill in a certain domain, then you might not be able to solve a case in that domain, or you might not be able to uh, extract insight from that domain, because insight is all about what you know about that particular industry. For example, if I only gave you the value of stock prices and probably how they've been moving up and down over the couple of years, you might not be able to predict what the stock price will be in the future, because you are not a financial analyst. You only have data, but you're not a financial analyst. Financial analysts will have domain knowledge as far as the industry is concerned. If it is financial sector, they could say because it's going to be an election year, most likely the financial sector is going to be hit. Not because the shares are bad and all that, but because everybody wants to hold their money. So that is what you're referring to as domain knowledge. You know about a specific industry to be able to make or gather insight on the effect of whatever data you have collected, you've gathered clues and analyzed, and how the insights are going, or rather extracting the insights and how to use those particular insights. So in terms of data science, there are 4 key things that are going to happen. You're going to collect the data, you're going to clean the data, which means you want to remove errors, you remove outliers and all that. Then you're going to analyze the data to find insights. Then you're going to visualize, which means you're going to share results, patterns, what you have seen in terms of graphs, they could be in terms of tables, they could be in terms of cards. It really won't matter how you want to present it, but at the end of the day, you basically want to be able to present this knowledge or insight moving forward. So let's look at relationship between AI, machine learning, and data science. We have explained what AI is. We have said it is the branch of, it is where we try to give computers and machines ability to perform tasks that previously were able to be done by human beings. And we say that ML is a branch of AI which is involved in training machines on data to be able to get patterns and now be able to produce predictive models. And of course, we have said data science is where we want to use multiple disciplines or methods to process data, algorithms, and systems to extract knowledge and insight from the data that we have gathered. So those are the three main contents or definitions we have used for the three components. So let's look at the hierarchy to begin with and see how the relationship is. AI is the broadest concept, which means it's the umbrella term for all the technologies that enables machine to mimic human intelligence. Machine learning is a subset of AI where we have a specific approach with AI where systems learn from data. And of course, we have deep learning, or sometimes data science is part of deep learning, not exclusively, but sometimes, where we now use advanced ML or neural networks to do what we call um, multiple node processing, where you don't only do one item at a time, but you're using multiple nodes to be able to make better inferences or decisions. So, for example, like a self-driving car, it will continually take photos of the road, and each photo is going to be converted into multiple nodes so that you're able to detect if this is a pothole or it's a person or it's a road sign or whatever it is, that can be able to act fast enough. So that's what deep learning is all about. So data science is an overlap. As we have said, data science will overlap both AI and machine learning, but it's just a subset of either. Data science will use various tools, including AI and ML, to extract insights from data. So data science uses ML and AI as tools, among many others. And of course, also, AI and ML can exist without data science. So it means that this can be a purely technical information. So data science is broader, which means it includes things like statistics, data visualization, and domain expertise. So when it comes to data science, you must have expertise on the domain. Unlike AI and machine learning, where that is actually optional, you don't necessarily need to have it. So the key takeaway here is that all machine learning is AI. So machine learning is a type of AI, and not all AI is machine learning. So AI includes other approaches too. Data science uses both as a tool, so it overlaps both of them. So they're not mutually exclusive, and especially when talking about data science and these other two, which is AI and ML. So data science will overlap the two spaces altogether. So let's look at some of the roles that you can do for the three industries that we have just mentioned. So we have an AI engineer, we have a data scientist, and we have a data analyst. So an AI engineer, the primary focus is to build and deploy AI systems and machine learning models. So the key responsibilities is to develop machine learning models, they deploy AI models, optimize performance, and build AI infrastructure. What skills do you need for an AI engineer? You need Python, machine learning frameworks, like the large language models. We have GPT, we have Gamma, we have Llama, there's Kimi K6. We have a lot of large language models out there, but of course you need to understand the large language frameworks. We have cloud platforms like Hugging Faces or Open Router and all that, which you can be able to use to connect to your IDE on and run AI models and even train the AI models by giving them more data or extracting the insights. And also, you need software engineering skills. You need to create a user interface. You need to create program logic when, like maybe checking for data consistency and then blank data, properly unformatted data, and all that kind of stuff. That's basically software engineering. Maybe you're creating a mobile app. Maybe it's a website. Maybe it will depend. It will all depend on what you are really interested in. But that's basically what an AI engineer does. They develop ML models, AI models, optimize performance, and also build the AI infrastructure. Data scientists, on the other hand, their primary focus is on analyzing complex data, building predictive models, and solving business problems. Remember, the AI engineer does not analyze this data. They simply pick what has already been analyzed, then develop a model for what has been analyzed. So that's the difference. So the key responsibilities for data sciences is to explore or analyze data, build predictive models, find business insights, and of course, communicate the finding. The skills that you need for this could be things like statistics. You need Python or R. languages, you need machine learning techniques, you need data visualization techniques, and of course, you must be a domain expert. You need domain expertise, whatever domain you're operating on, whether it's medical, whether it's financial, whether it's architecture and all that. You need to be very tech averse in or info averse in that particular area. Then we have data analyst. The primary focus of the analyst is to interpret data, create reports, and visualization to support the decisions. So the key responsibilities will be to clean and organize data, to create dashboards, to generate reports, and also answer business questions. Now, the skills that they need will be things like SQL, Excel, Tableau, Power BI, statistics, and basic communication skills. So you can see when we are talking about roles, we have AI engineer, data scientist, and data analyst. All of them do different things altogether as far as this AI industry is concerned. On one end, I have somebody who collects the data, who cleans it up, and creates dashboard and report. On the other hand, I have somebody who analyzes the data, they build a model for it, they find insights from that data, and they communicate their findings. Then you also have somebody now who picks that data, they develop a learning model for it. They develop AI applications which utilize, of course, the machine model, and of course also the optimize performance and build the infrastructure altogether. So that is ideally what those three key roles do. So the key differences are as simple as follows. AI engineer will build the AI system. Data scientist will solve the complex problem. In short, they'll pick the problem, then they'll give solution to that problem and hand over the solution to be developed by the AI engineer. Of course, data analysts will create insights and reports, which means they will gather the data, they will arrange it in a certain way that is understandable, hand it over to the data scientist who can now be able to look at patterns and come up with complex solutions to that particular problem that the business is actually facing. So here I want us to have an interactive exercise where we have tasks here, and I wanted us to be able to identify where they fall. They can either fall in the three categories, either AI, machine learning, or data science. So probably I'll give you this task to be able to complete. Then when we meet next time, we'll see how far you went with it, and of course, why you picked whichever category, and see if that works or that does not work. Again, I'm simply saying blindly, it could fall in more than one category. It only depends on how you justify your data. So let's look at applications of AI. We have looked at this, so I just want to look at them again from a broader perspective so that now we can have a close for this. So how platforms suggest contents you might like recommendation systems. So the concept here is the recommendation system will predict what you might enjoy based on your behavior and preferences. So the simple explanation, because they use completely different algorithms, which I don't want to get into, they will analyze what you like, rather what you watch, what you buy, or what you click. They will find people with similar tastes and suggest what similar people have enjoyed to what you're looking at. So in a nutshell, that is the basic principle of how a recommendation system works. Real world examples are things like YouTube. YouTube will suggest videos based on your watch history, or based on your likes, based on your subscription, and maybe do what we call recommended for you section to see what you might like. So as you click on what is recommended for you, it keeps on learning your habits and what you like. Netflix also recommends shows based on viewing history, ratings, and similar user preferences. So as you can see, there's history. YouTube does not have rating, but it has likes, which is similar to ratings, and of course, similar user preference, which is more like the subscription that you make on YouTube. But of course, also there are other users who probably like the things that you like, so probably that's another algorithm that they can be able to use. So we also have Jumia or Amazon, which suggests products based on browsing history, purchase, and what similar customers have bought in the past. So how it works is as simple as one, they collect data, they track what you buy, what you click, and how long you engage. So if you watch an advertisement for more than 40 seconds, it means that that could be something of your interest. So they log that and they pick it as one of the filters that they want to apply based on what you want to look at. Then they want to find patterns, which is the second part, identify similarities between you and other users or between items. Like for example, when you buy a laptop, most likely you'll buy a laptop bag. Goes without saying that most people who buy laptops will also buy laptop bags. As simple as that. So when they're trying to find a pattern, most likely if you're buying a laptop, you could also be looking for a bag or an external mouse, for example. So they will do the recommendation of that because that's what most other people have bought together. Then, of course, 3 is making suggestions, which means they will recommend content or products you're likely going to enjoy based on the patterns that they have identified in your history. Then the other application of AI is fraud detection. So fraud detection system use AI to identify suspicious transaction and predict and protect rather your money. So how does this work? They learn your normal spending patterns. They flag transactions that deviate from that normal pattern, and they alert you or they block suspicious activity. So, for example, is unusual time transaction at 3 a.m. when you are normally asleep. So your phone or the app can be able to detect that you're sleeping right now. So most likely you might not be the one trying to transact, and that flags as a suspicious transaction. Strange location, for example, you want to purchase in Nigeria when you're in Kenya, or maybe even large amounts of transfer, maybe 100,000 when you usually just send 500. And of course, rapid transaction where somebody is trying to perform multiple rapid transactions in quick succession. So it's able to detect all that. So these are just some of the flags that I'm saying it could use to be able to detect a suspicious transaction, then flag it off or even put a stop to it until you probably authorize the completion of that particular transaction. So that is fraud detection and a very important application of machine learning and artificial intelligence. We might do a project on this if time allows, so that you see how it is actually implemented in real life. So there's also critical thinking about AI and reliability and ethics. And things are what could go wrong. I mean, AI isn't all perfect. There are things that could go wrong. So what if things go wrong or it makes mistakes? What do you do in that case? Or rather, how can you prevent it? This is something that is in discussions in many forums. For example, think about financial systems. When a fraud detection system fails, what is left for us? When healthcare diagnosis fail, it fails to diagnose data properly. What happens? Transportation, when self-driving cars are involved in too many accidents, what do we do? When we get wrong information from recommendation systems, whatever it is recommending is always wrong. What do you do? So those are things we need to look at. And the scenarios that I gave you would be like, for example, in fraud detection fails, millions will lose to fraud, people lose savings, trust in digital banking is destroyed. So are we going to go back to traditional banking where I have to go to the bank and withdraw money from the bank? That's not likely going to be scalable at the moment. So again, we need to think about that. Recommendation system could go wrong, maybe spread information, create echo chambers which manipulate opinions. Like right now, what most celebrities do is they buy likes. And we have what we call click farms, where somebody has about 10,000 phones, all of them opening YouTube, and they can just click on the same video. So within a very short time, they have 200,000, 300,000, 500,000 views within 2 or 3 days. But actually, these are not people. So it might mislead the advertisers into thinking that somebody has a very large following and people like their content, whereas we're talking about robots are the ones clicking these systems, and as such, they're not real customers over there. So that is spreading misinformation. We can create what we call echo chambers and manipulating opinions, as I have put it. Then you have medical AI, which can make errors. The consequence is that you might diagnose wrongly, there could be delayed treatment, or patients could be harmed, or they could even die based on misdiagnosis. You prescribe the wrong drug for the wrong diagnosis. Then, of course, for autonomous vehicles, accidents, injuries, or death, or even legal liabilities are questions that can become something that we're dealing with on a day-to-day basis. So again, when we're talking about AI, we need to consider what might go wrong. We have seen the advantages, we have seen how it works, we have seen how powerful it is, and we have seen the advantages that it comes with. What's important is how exactly can it go wrong? And the discussion that you need to have is what do we do when it goes wrong? So as I've given examples over there, just need to, you know, put your head around it and try to figure out, well, if this were to happen, this is now critical thinking, then how can we be able to solve this problem without removing AI from the equation? Because at the moment, we cannot actually do without it. Then we have daily AI, which is our last topic. How do you use AI daily? And again, we have looked at these examples 1,000 times. Predictive text, which means it suggests for you the next word as you type. So it learns from your vocabulary and style. If you open any app that requires you to type, maybe a message or WhatsApp or even an email, you realize that your phone is able to predict what you might want to tap next, and most likely you'll just be clicking next word, next word, next word, next word, next word until you're done with the entire sentence, so to speak. We have facial unlock, where you can unlock your phone based on your facial recognition, regardless of whether you're wearing specs, you're putting on a hat, you've grown beard, and all that. It will still be able to to recognize you. We have voice assistants like Siri, Google, or even Alexa, which will allow you to do things hands-free. For example, I can simply open my smart TV and search something on YouTube without necessarily typing. Right? That's an example of a voice assistant. Then you have camera enhancements, things like scene detections or what you call filters, portrait mode, night mode, and so on and so forth. The cameras have become so intelligent, they're able to detect modes, they're able to blur the background, they're able to lighten your face, they have different effects for you and all that. All this is now application of AI on smartphone and social media, which is what we use on a daily basis. Then there's also social media, which means you're talking about personalized feeds. This is where algorithms will show you content based on your interest, engagement, and behavior. We also have content moderation, where AI will detect and remove harmful content, hate speech, misinformation, copyrighted material, and so on and so forth, without necessarily involving a human being. Right now, if you took my video and you upload it on YouTube and I say that's copyrighted content, it will not even take 5 minutes before they bring it down. And you can imagine the scale at which videos are downloaded, are uploaded rather on YouTube. It's at an alarming rate. It's impossible for human beings to look at the content as comes in and be able to flag what is copyrighted and so forth and so forth. So again, that is actually a very powerful feature. Of course, I know it makes mistakes, but at the end of the day, 90% of the time, it is usually right. So we also have friend suggestion. It recommends people you might know based on mutual connection. It could be looking at distance, it could be looking at connection, it could be looking at your phone book, maybe your interest, maybe proximity in terms of geographical location, and so many other things. So friend suggestion is another useful feature on daily AI that we have. Then you have target advertising, which means we want to show ads based on your interest, location, and maybe even online behavior. Right now, if you go to WhatsApp and you tell your friend that you're looking for new shoes, go back to Facebook and you'll see all the advertisements are based on shoes. That's exactly how target advertising works. It simply tries to learn what you are looking for, then tries to make suggestion based on that. So what I wanted you to do is to reflect on how much of your daily smartphone use involves AI without you realizing it. You can see literally your whole mobile phone ecosystem is actually AI based. Even that right now is when they're telling you that the phone has AI. That is a lie. From 10 years ago, your phone has been collecting a lot of data, and this data has been used to train AI. And this AI, in as much as it does not live on your phone, it has been used over time to be able to do the things that I'm showing you here: content moderation, personalizing feed, friend suggestion, target advertising, amongst many other things that they have used that data for. That should explain to you why WhatsApp does not charge you for anything, but they provide you with the service, and the company is valued at billions of dollars. What business exactly are they engaging in to make it valued so high, whereas they don't have any single paying customer directly, right? So that's food for today. Another application on daily AI is navigation and banking. So in navigation, you can get real traffic update. So it can predict traffic congestion using data from millions of users. It can optimize routes, find the fastest route considering traffic, road conditions, and even time of the day. And ETA prediction, it can accurately estimate arrival time based on current conditions, weather, traffic situation, political activities going on, weather patterns, and so many other things. It is able to do that accurately. In banking, you have fraud detection. We have detected that. Spending analysis, it can categorize your expenses, showing new spending patterns and trends. It can provide financial advice, personalized tips for saving, budgeting, and financial goals, and even credit scoring. So most banks now use AI for credit scoring. What they do is that they simply look at the activities in your bank account, and of course, if you're listed in CRB or not, then they can be able to score you and say Richard qualifies for 10,000, as simple as that, or Richard qualifies for 100,000, something like that. So they do not necessarily need somebody to sit down, look at your account, do all the mathematics, perform the risk analysis, then determine how much they can give you. AI actually does that for them flawlessly. That's why we have banks now giving you mobile loan, which do not even require you to fill in a form. Simply go to the app, say you want this loan, say how much you want, they'll give you a limit, you're able to get that money, and of course, they know that you have the capability and the willingness to pay. You are a less risky customer. So my last topic here was a group activity where I wanted you to identify 5 AI systems. So your mission is to identify 5 AI systems used daily and explain what type of AI or ML they are. So because we are small, we can do this individually, and the categories I want to explore are the 6 on the left. Look at communication, entertainment, finance, health, education, and transportation. So I want you to identify 5 AI systems you use in these 6 categories. Just list them for me and identify what type of AI or ML, what type they are. Are they an AI or an ML? Then when we come back, we can be able to discuss the details. I think I'll take a break at that. So the screen here is basically a takeaway on what we have learned today. So it's basically a summary of what we have looked at and application areas. So I'll just give an opportunities for questions and then I'll answer them or comments. Then I think we can call it a day and resume on Monday. Any question?
I have a question.
Go ahead.
In reinforcement learning,
Okay.
you said that in reinforcement learning, you said that we train models through reward and penalizing. How
Yes.
do you reward and penalize such models?
It's as simple as what I said. Like for example, let's say you want to train a self-driving car. Maybe say you want it to be as autonomous as possible. So the reward would be every time it arrives at the destination without incidents on time. So there is arriving on time and incidents. So if those two conditions are existing, then you reward it a point. Okay. So there's a point that is awarded. Now, every time it arrives late or it's involved in an accident, you deduct a point. So it means that it's not going forward. So when you have more negatives than positive, it means that you're doing the wrong thing. So shift your thinking from how you are doing things into how you could do things better. That's how reinforcement learning kind of like works. So I will give 2 scenarios, a reward and a penalty. Reward for something positive, penalty for something negative. The more the negatives, it means the less you have learned, the less experience you are, and as such, you cannot be able to move ahead. The more the positive, it means you're doing the right thing over and over again, and you are encouraged to do the exact same thing that you have been doing over and over again. So for penalty, we want to discourage you from doing whatever you have done because whatever action you might have taken resulted into an accident. For example, you took a wrong turn, which resulted into an accident. Next time, you're not going to attempt to take a wrong turn because you know that doing a wrong turn means that you're likely going to be involved in an accident which leads to a penalty. So instead of taking a wrong turn, just take a longer route, arrive a little bit later, but without incidents, and then that is probably half a point or something of the sort. That's how reinforcement learning works. Similarly to like training a dog, as I said, when you tell a dog to sit down on a command and it sits, it gets a reward. Either you pat it on the back, you give it a snack or something of the sort. When a dog jumps on the couch, then you penalize it by not giving it food for that day or locking it up or something of that sort. So it knows that when it jumps on the couch, there's going to be a penalty, which is going to be either locked up or not getting any snacks. So it will try as much as possible to avoid jumping on the coach. That's kind of like how reinforcement learning works. I don't know if I have.
Okay, thank you.
Yeah. Another example is on robotics. When you're training a robot on movement, sometimes you're training it on grasping things or performing certain movements correctly. If it grasps something correctly and accurately, you reward it, you give it a point. When it does not grab something and maybe something falls off or it misses and all that, then you penalize it. Next time it knows that maybe the angle was wrong, maybe the force use was so much. So it's able to, because we're not telling it exactly what to do, we're just giving it rewards and penalties based on how best it has performed a task. It is now able to reinforce itself and know this is right, this is wrong, and so forth and so forth. Okay? Any other question? We're going to look at this practically, don't worry. We'll create a simple project that implements this in Python, so you'll see how that works out. But it's good to learn to understand the principle first before you attempt to do the implementation. All right?
Yes.
Any other question? No question. Okay, if there's no question, I think I'll take a break at that. I will share this presentation. I've also recorded this as a video for those who might want to follow it later. You can I can also share it on the resources part of the class. Then we'll see how to move along with our next chapter. Okay, so have a wonderful evening, and let's meet again next week on Monday. Then we can move on from where we have